Now, at the core of naive Bayes classifier, and this is what makes the naive Bayes classifier naive, is the independence assumption. So up until now, we were just talking about Bayesian classifiers in general, not naive Bayes. Now it becomes naive. And where it becomes naive is we need to compute these model-based probabilities. So we must compute P of x given y. And the reason it gets difficult is our x is not just a single variable. Our x is actually a bunch of variables. We have one variable for every attribute that we have. So if x is our bitmap, and we're trying to recognize that bitmap consists of a bunch of pixels. And we have one attribute for every one of these pixels. So what we're really computing, it's not just x given y, it's x consists of a bunch of variables. Maybe, so for bitmaps, it's 400 variables. And we want to compute the probability of 400 variables taking on particular values, assuming that we're in the digit 3 or digit 6 or so on and so forth. And the reason this is difficult is because the normal, the easy way of estimating probabilities doesn't work anymore. So the easy way of estimating probabilities is you count, right? If you want to see, if you have one pixel and you're just estimating the probability for that one pixel, you count how many digit 3s have that pixel as black, how many digit 3s have that pixel as white. And you have two numbers, and you can work with those numbers. When you have 400 digits, counting becomes difficult because you're never going to see repetitions. You're never going to see anything more than once. And the reason for that is, think about the total number of bitmaps that you're considering, right? If you have a 20 by 20 binary bitmap, that's 400 variables. Each pixel could either be 0 or 1, black or white. So you're talking about 2 to the power of 400 possible bitmaps. That's how many bitmaps there are there. And what you are asked to do by the Bayesian classifier is to compute the probability for every single one of those bitmaps given class 3. Right? And that's just not feasible. You cannot even enumerate them. And you will never have the data to count them. So you cannot possibly get this number by counting them. And that's just bitmaps. If you work with text, your event space is a lot bigger than that, right? So it's hopeless. Now, the way to get around that, when you cannot compute a probability directly, you start making assumptions. That's what probability theory tells us. And in this particular case, the simplest possible assumption you can make is you can assume that the variables in your representation, the attributes or the pixels, are independent of each other. So if they're independent of each other, then you can factor out this joint probability, P of x1 through xd, given the class y. You can factor it into a product of the marginal distributions. And that's usually done in 2 steps. So what you do is you have d different attributes. So in terms of pixels, this would be 400 pixels here. And what you do is you peel them off one by one, right? So you take pixel 1 and look at how many times, what is the probability that pixel 1 is black, given that my class is 3, right? Next, you peel off pixel 2, you say, what is the probability that pixel 2 is black, given that pixel 1 was black and the class is 3. So that's this nested formula. You're breaking a joint distribution into a product over all the individual attributes, and you're one by one putting these attributes into the conditioning part on the right side of the vertical bar. So that part is just a chain rule, right? It's exact. You can always do it. It doesn't involve any kind of an assumption. The assumption comes here. That's the independence assumption. The independence assumption is when you're saying, okay, I want to see what is the probability that the ith pixel is black, given that I'm in class 3, and I have a bunch of pixels that came before I, and I would love to condition my probabilities on those pixels, but I just can't. There's too many of them. So what I'm going to do is I'm just going to assume that pixel I is independent of all the pixels that came before it, and only depends on the digit, on the class. That's the independence. That's the independence assumption. And the reason it's attractive is now I can count each pixel individually. So I can take pixel 1, that one, and just by itself count how many times was it white and how many times was it black for digit 3, how many times was it white and how many times was it black for digit 6, and overall classes like that. And then I'm going to repeat that for every single pixel, and I'm going to have plenty of data to estimate those. So that's the reason why you do it.